Welcome everyone. The question that is shown on the screen, it is an assertion and reason based question of the question number 13 of the CBSE sample paper 2025. The assertion, the first statement is, on increasing the current sensitivity of a galvanometer by increasing number of turns may not necessarily increase its voltage sensitivity. What is the reason? And the reason is said, the reason of the coil of the galvanometer increases on increasing the number of turns. Four options are given as usual. If both assertion and reason are true, reason is the correct explanation of the assertion. If both the assertion and reason are true, but reason is not the correct explanation of the assertion. If the assertion is true, but the reason is false, and the option D is if both the assertion and reason are false. Okay, so for that purpose, let us how the galvanometer actually operates. Okay, a galvanometer is nothing but is a rectangular coil is kept in between the pole pieces in a uniform magnetic field like this way. In a uniform magnetic field, when the current is flowing through the coil, obviously a torque BINA acts, and that is the cause of rotation of the coil, and when the pointer is attached on it, and that basically slides over the scale. Now obviously with the galvanometer coil, a spring is attached here. A spring is attached, and the spring is basically producing the restoring torque to restore itself in its initial position. So from that, the tau is, you can say tau is proportional to the torque, which is proportional to that of the theta. Okay, as much as torque you will give, more rotation will be there and more restoring torque will generate, and from that we can say that is BINA, that is equal to C multiplied by theta, where C is a constant which is called a restoring force constant, which is basically depending on the instrument, depending on the apertures. So BINA equal to C theta. Now here they are talking about what is the current sensitivity. Okay, so from this expression, it is the hidden gem actually. The current sensitivity, okay, from which expression it is designed? It is designed from the expression theta divided by I. Okay, that is if you send unit current, how much the pointer on the scale deflects. Okay, pointer on the scale deflects. For your reference, I can say, if I say this is the scale, it is starting from 0, this is 1, this is 2, this is 3, and this is the pointer which is rotating over there. If you send a unit current flow, okay, then how the pointer on the scale deflects. So if you calculate theta by I from here, I hope you understood that is B in E. Okay, obviously here if you just able to keeping this magnetic field constant and the cross sectional area of the coil is constant, capital A, the area of the coil is constant, then C is the constant of operator. So one thing you can easily do, and by this you can increasing the current sensitivity, that is the number of turns. If you increase the number of turns from that expression, then what will happen? The current sensitivity, if I denote it by theta S, which is actually theta by I, that will increase. So it is said, on increasing the current sensitivity of a galvanometer by increasing the number of turns. Okay, so up to this the statement is correct. May not necessarily increase the voltage sensitivity. So similarly, if you try to define what is voltage sensitivity, we can say that is theta V. That is, similarly it is defined as theta divided by V. That is, if you change unit voltage, what is the deflection? What is the deflection of the pointer on the dial? Okay, so very simply we can say that theta divided by I multiplied by R. Okay, so if you just increase the number of turns, if you increase the number of turns of the coil, then you are increasing nothing but the length. Okay, So if I write it down, it is theta by I multiplied by 1 by R. So theta by I already we have observed it is BNA divided by C, and R equal to, all of you know this, rho L by A. Okay, rho L by A. This A is the cross sectional area of the wire. Okay, not the coil, but this A is the cross sectional area of the coil. So let us say this is, I am giving, this is A prime. Okay, that is not changing here. Okay, cross sectional area of the wire which is basically wounded, and after that the coil is made. So it is BNA. So BNA divided by C, it will become A prime divided by rho multiplied by L. So from it I think theta V, we can say it is proportional to N divided by L. Okay, N divided by L. If you increase the number of turns, obviously the length is also increases. So depending on this proportion N by L, the voltage sensitivity increases, and if the length increases much more than that of the ratio, if the length increases much more than that of the number of turns, okay, then obviously the voltage sensitivity decreases. I am talking about if you just increase the number of turns in such a way that N by L is less than 1, then theta value will decreases. But if you increase the number of turns in such a way that N by L is greater than 1, then obviously theta v will increases. So always by increasing the number of turns means you are increasing the voltage sensitivity. By increasing the number of turns you are increasing the current sensitivity and thereby the voltage sensitivity. Always it is not, it is depending on the ratio N by L. So this statement is correct. The resistance of the coil of the galvanometer increases on increasing the number of turns. Perfect. We are basically saying this thing logically on this. So obviously reason is the correct one. Reason is also the correct one. So obviously assertion and reason both are true here, and reason is the correct explanation of the assertion here. Here the reason explains the assertion why may not necessarily increase the voltage sensitivity. Thank you all of you.